I welcome you all. We are discussing some most important topics which are linked to this physics, and so many questions are asked further related to this topic. That is, one of the most important question is why the sky is blue. So we will find the answer of this question. So let's start. Not all colors are the results of addition or subtraction of light. Some colors, like the blue of the sky, are a result of selective scattering. Consider the analogous case of sound. If a beam of particular frequency of light is directed, a tuning fork of similar frequency, the tuning fork is set into vibration and redirects the beam in multiple directions. The tuning fork scatters the sound. A similar process occurs with the scattering of light from atoms and the particles that are apart from one another as they are in atmosphere. If you look at the figure, here it is. This is the process how the scattering takes place. A photon enters from the stationary atom, collides with stationary atoms, and what happens with the wavelength of the incoming? It changes in the direction of the motion of the photon changes. Where we learned that atoms behave like tiny optical tuning forks and re-emit light waves that shine on them. Molecules and large collection of the atoms do the same. The tinier the particle, the greater the amount of higher frequency light is. It will re-emit. The tinier the particle, the greater the amount of the frequency of the light it will re-emit. This is similar to the way a small bell rings the higher notes with the larger bells. This is similar to the way small bell ring with higher notes than the larger bells. The nitrogen and oxygen molecules that make up most of the atmosphere are like tiny, tiny bells that rings with high frequency when energized by sunlight. Like sound from the bells, the re-emitted light is sent in all direction. When the light is re-emitted in all directions, we say that the light is scattered. When the light scattering takes place, when the light is re-emitted in all directions, we say that the light is scattered. Of the visible frequencies of the light is re-emitted in all directions, we say that it's scattering. Now, of the visible frequencies of sunlight, violet is scattered the most by nitrogen and oxygen in the atmosphere, followed by blue, green, yellow, orange, and red in that order. Red is scattered only a tenth as small as violet. Although violet light is scattered more than the blue, our eyes are not very sensitive to violet light. Therefore, the blue scattered light is what predominates in our vision, and we see blue sky. The blue of the sky varies in different locations under different conditions. A principal factor is the water vapors content of the atmosphere. On clear, dry days, the sky is a much deeper blue than on clear days. With high humidity in the location where the upper air is exceptionally dry, such as Italy and Greece. Beautifully blue skies have inspired painters for centuries. Where the atmosphere contains a large lot of particles of dust and other particles larger than the oxygen and the nitrogen molecules. Light of lower frequency is also scattered strongly. This makes the sky blue. and it takes a whitish appearance. After a heavy rain storm, when the particles have been washed away, the sky becomes deeper blue. The grayish haze in the skies over large cities is the result of particles emitted by car and truck engines and by factories. Even when idling, a typical automobile engine emits more than 1,000 billion particles per second. Most particles are invisible, but they act as tiny centers to which other particles adhere. These are primary scatters of low frequency light. The larger of these particles absorbs rather than scatters light, and brownish has it to produce the reject. So this is the concept how the sky looks blue, and uh, we are, have understood how the color of the sky is blue. I thank you very much for your attention.